Okay, so in this video, we want to attempt to find the following limit, not using direct factoring, as in the previous case, as we know that this is going to fail, but instead trying to transform this expression using the method of conjugation. So we know the case is positive infinity minus infinity, and let's try and conjugate this expression to try and maybe transform the problem, and maybe this will give us a new angle of approach. The conjugate, of course, is the exact same thing, but changing the sign. So as we have here a positive, we will now flip it to a negative. Everything else will remain the same. And of course, to cancel this multiplication, we have to divide by the exact same term. As something over itself obviously cancels to 1. So we are only changing what the expression looks like, not what it is equal to. Let's perform this conjugation, and let's see how this transformed the case. And again, it's worth pointing out that before the conjugation, the case was, as we previously stated, positive infinity minus infinity. So on the numerator, this times itself, the root cancels, which gives us 4x squared plus 6x plus 1. Then the root times negative 2x, and then positive 2x times the root cancels to 0, and of course, negative 4x squared. Over the second part of the conjugation. This times 1 stays, of course, itself. And now we can obviously simplify. 4x squared minus 4x squared cancels to 0. And let's see what we're left with. So on the numerator, 6x plus 1. On the denominator, again, the second part of our conjugate. And now we can check the case to see if we've made progress. So as x goes to negative infinity, the largest term on top is 6x, which also goes to negative infinity. On the denominator, in the first case, the dominant term is 4x squared, which goes to positive infinity. The root of infinity is infinity. And then negative 2x, which goes to negative infinity, therefore also positive infinity. So we have infinity plus infinity is, of course, infinity. So now we have again an indeterminate case of the type infinity over infinity, but this we can handle. This will be solvable by direct factoring on top and bottom. So the trick here was that we couldn't factor directly at first. We had to conjugate. And now we can use the factoring of the largest power of x. So on the numerator, we have an easy factoring. Of course, the term is x, and we're left with 6 plus 1 over x, divided by, well, we can't quite factor the x first from the whole expression, so we have to factor first inside the square root an x squared. If we do, what remains is 4 plus 6 over x plus 1 over x squared, then minus 2x. And now, of course, here we'll use, in the same go, two properties of the square root. We have the root over a product. This is, of course, in general, root of ab if a and b are positive, the root of a times the root of b. This will give us the root of x squared. And again, here we have to be careful. If you square something, then take the positive branch of the square root, it returns what's inside, but an absolute value. Since an even power of a negative is positive, and an even root of a positive is also positive, and since x is approaching negative infinity, x is clearly negative, therefore, to make a negative become positive, we have to negate it. So now we can replace the root of x squared by negative x. And then we'll be able to factor in x from the denominator. So as we've just said, the root of x squared is negative x times the root of the second term and then minus 2x. And now x is a proper multiple of each of the two terms, and it can be factored, and this will resolve the case. So on the numerator, nothing changes. And on the denominator, we have a choice to either factor simply x or also factor negative x. It doesn't matter. I'll factor here negative x. This will leave us with the square root of 4 plus 6 over x plus 1 over x squared. And if we factor negative x, we're left with positive 2. We can now cancel the x over x. And so on top, we're left with 6 plus 1 over x. And on the denominator, the negative remains, and the other two terms are left unchanged. And we can now let x approach negative infinity. And as we do, 1 over x shrinks to 0, 6 over x shrinks to 0, 1 over x squared shrinks to 0, and so we're left with, on the numerator, positive 6, over negative of, well, this one will be approaching root of 4, which is 2, plus 2, therefore is approaching 4. Common factor of 2 we can cancel, so we're left with, in the end, negative 3 over 2 as our final answer. And so whereas in the first attempt direct factoring of x did not work, we can now easily fix it by first conjugating, simplifying, and then the direct factoring works, and will also always work in an infinity over infinity case. And that's it.